NCERT Exemplar 12th standard physics syllabus electric potential and capacitance in the heading question number 22. Papma, calculate the potential energy of a point charge minus Q placed along the axis due to a plus Q uniformly charged distributed along the ring of radius R. Sketch potential energy as a function of axial distance Z from the center of the ring. Okay. Looking at the graph, can you see what would be happen if minus Q is displaced slightly from center of the ring? This is a ரெண்டு question இதில் combine ஆயிருக்கு. It is given clearly there is a ring in which charges plus Q is distributed throughout the ring. Okay, charge is plus Q. On the axis, this is a midpoint on the axis. We imagine this is called Z axis. We imagine a point P. In the point, we are keeping minus Q. Okay, we are keeping a minus Q. First, we wanted to find out a graph. The graph should be, or we are going to draw a graph. A graph is drawn between potential energy versus Z-axis. We assume this is a Z-axis. This is plus Z-axis. This side is minus Z-axis. We know at the potential energy will be when we take this is the charge. First, we will find out mathematically what is the potential energy between the ring and the charge. Okay, what is there? Here, charges are distributed over the length. There is a linear charge density, charge by 2 pi r, where r is the radius. Okay, then we assume this is in Z-axis, and this is the point P, and middle point is taken as O, and this end is we assumed as A. First, we will find out what is potential at the point due to plus Q. Potential at a point due to a small portion. We will take it as dq is a small charge present in the small portion. We know the formula. Small potential at the point is, let us take it as dV. Small potential at the point due to small element dq is, we know the formula dq divided by 4 pi epsilon naught, this distance AP square. AP, potential, very AP now. So this is the potential at the point AP, the distance AP. Now, what is AP? AP is nothing but hypotenuse. Let us take this as Z-axis Z, this as R. AP squared will be equal to Z squared plus R squared. AP will be equal to small potential due to the small portion dq will be dq divided by 4 pi epsilon naught into root of Z squared plus R squared. What is dq? We know linear charge density is charge small portion by length. We know the length is small l dl. This length is a small l dl. Having a charge dq, dq will be equal to, instead of dq, we can substitute as lambda dl. 1 minute. Lambda dl. This is small potential. Namakku total potential venapo. Total potential is integrate பண்ணுவோம் closed integral of this surface. This integration is up. Let us take this. This integration is applicable for dl. What is dl, which is nothing but 2 pi r? 2 pi r. Again, substituting the value lambda into dl divided by 4 pi epsilon naught into z squared plus r squared to the power of half. And instead of dl, we are going to substitute 2 pi r. That's all. We will have a formula lambda into 2 pi r divided by 4 pi epsilon naught into z squared plus r squared, z squared plus r squared to the power of half. This is potential at the point due to this ring. What is the potential energy? Potential energy is QV. Here the charge is minus QV. The formula will become Q into lambda into 2 pi r divided by 4 pi epsilon naught into z squared plus r squared to the power of half. That's all. This is the formula to calculate potential energy. And the potential energy with axis, the diagram, potential energy at the center will be minimum. Then it will increase and go like this way. This is plus z axis, this is minus z axis. So now we have taken in plus potential energy, and the most important is potential energy we have calculated in between, and from the formula it is clear. We can cancel this. 2 pi r is nothing but lambda into 2 pi r is nothing but, what is the value? Q. Formula will become small q into capital Q divided by 4 pi epsilon naught into z squared plus r squared to the power of half. Potential energy ko distance ko the z axis pata inversely proportional to z da potential energy. Distance kuda here there is a minus sign. So potential energy will decrease. That's the meaning of this. As the distance increases, both sides. This is the formula for inversely proportional to Z also and Z. Anyway, this is the graph. And the most important is, if the charge, here this is plus and this is minus, and potential energy we have found. If you pull the charge away, it will be attracted. So, when you bring the charge upward, it tends to oscillate. So, conclusion is, the charge would perform oscillation and the charge displace slightly from the center of the ring. The center of the ring is laser displaced panna. When you displace the charge, it will tends to oscillate because of the balancing force offered on both sides. This is the conclusion. Okay. Thank you for listening.